Hi everyone, welcome to Happy Quantum Chemistry class. Do you like diamond? Diamond is known as the most valuable jewel. However, this is not everything about diamond. Have you heard about nanodiamond? Nanodiamond means diamond which scale is very small, about few nanometers. There are four kinds of nanodiamond depends on its synthesis. The smallest one is diamondoid less than 1 nanometer size, which is extracted from crude oil. Next is DNDs, size is 4 to 5 nanometer, mostly produced by controlling detonation of TNT-like explosive in a closed vessel. Recently, we also can produce DNDs by pulsed laser ablation. Third is pure nanodiamonds. Size is 5 to 100 nanometer, which is grounded from large crystal. The largest is crystal plate. It can grow almost 10 millimeter, and we usually synthesize it in high pressure and temperature conditions. Recently, chemical vapor deposition method is also used. Purity of those nanodiamonds are like this. Diamondoid is too small to be stable. Has interior defects, and DNDs are better than diamondoid but still difficult to contain a high proportion of sp2 like carbon. And third is much purer than DNDs, and single crystal plate is the purest one. To sum up, when nanodiamond is in small size, they are unstable and purity is low, which means that they have more defects in smaller size. Interesting thing is, this defect causes fluorescence. High purity and properly cleaned diamond is colorless and fully transparent, but if diamond includes specific lattice impurities or dopant, it has color. In other words, it fluoresces. We call this case as coloration, and it is also known as color center. There have been many research about the structure and physical properties of diamond defects till nowadays. The most iconic model system to develop a wide variety of quantum manipulation protocols is MV center, which consists of vacancy and nitrogen structure. This is one of the most looking for nanomaterial, especially as a biolabeling and qubits. MV center is apart from other defects because of its magnetic of non-zero spin. To know more well about MV, we should know about Rabi nutation and Ramsey fringes. Rabi nutation can describe the oscillation between two states of spin up, which means 1, and down, which means 0. And it can be used to determine pi pulse duration. Range of 100 degrees is interaction zone, so we call it pi pulse. Pi pulse is used to change the state of spin to opposite state from 1 to 0. The Hamiltonian of the rotating frame is like this, and the property of transition is like this. Next is Ramsey fringe, which is splitting one interaction zone of Rabi nutation zone into two very short interaction zones of pi divided by 2. MV spin is superposition state of pi divided by 2 pulse. Due to the interaction with nuclear spin, population oscillation is shifted. Hamiltonian of Ramsey fringes is same as the Rabi nutation. Probability is quite different. Ramsey one is much more simple. Spin echo is key of MV spin. With this, we can actually get the information about MV spin from signals. Because MV center spin is coupled with surrounding carbon nuclear spin, choosing right MV spin which is located close to the carbon nuclear spin and applying external magnetic field make coupled electron nuclear spins can be addressed. Through this process, we can get information from the nuclear spins. With spin echo, it is able to address isolated nuclei in solid and manipulate them by a nearby MV spin. If we run a pi divided 2 pulse and then run pi pulse, then we can get echo signal of pulse. After a pi divided 2 pulse, the signal decays a lot due to dephasing, so we use pi pulse to get more good quality of signal. Pi pulse eliminates the contribution of n nuclear spin and environmental magnetic field like left picture. Blue one is at the most right after pi divided 2 pulse and pi pulse at same position. Right after pi divided 2 pulse, average magnetization lies on plane. and spin begin to decreasing and dispersed to fast and slow spinning nuclei. At this time, if we run pi pulse, get coherence again. It is also called refocusing. At this time, we can get strong echo signal. This means that we can get information of spin of MV center by magnetic. This is spin Hamiltonian of MV center. Also, we can modulate spin of MV center by magnetic field. And since the luminescence of MV center coupled to spin state, so we can modulate luminescence of MV center by magnetic field. As there is a way that we can control it, we're also looking forward to use MV center in many industrial fields. For example, biomicroscopy, scanning probe microscopy, and animal spectroscopy, and so on. Still, there are some obstacles related to surface effects. This is real beauty of diamond. After this video, I hope you guys recall about MV center when you see diamond. These are my references. Thank you for listening.